All right, so this is another R&D project, a proof of concept for CyberEdge Group. We are recently trying to get into machine learning via TensorFlow.js. Here I am testing a model that created by Google already called the Mobilenet. This model has been trained with thousands of objects and animals and such. For example, once I load my image, I hit this, and right here it recognizes it as a lion. Let's try some more. For example, let's bring in the elephant. Boom, and it recognizes it. And now let's get a little bit more specific. Let's say bring in a dog, and this time it will recognize it not only as a dog but a bull mastiff. I mean, now it's being specific. I also have this going here so that I can at any time pull this stuff back quickly without loading. So now let's try another dog. Let's see if it can classify that one. Here we go, and it does. Also, I wanted to test out with my own images. For example, this guy right here. This is Major Ni-Hat, but let's see what we can get. Look, we get hairstyle swing and whatever that is. Let's try Captain Ni-Mat. We get the same thing. Yep, ice lolly, whatever, right? Now let's try a car that I used to have. Okay, and look at that. It's recognizing it as a cab or a hack or whatever, right? Let's try one more. Let's see if it goes even close. Yes, I mean, convertible, sports car, whatever, I mean, but still not exactly what I want it to be. So, for that reason, I went ahead and trained a model myself, which is this guy using Google's Teachable Machine. I classified these images, and then I trained it. And once I did, I tested it, and this is where it gave me the results. So now let's go to the code where I did that. So here it's a usual React app. I'm loading my states here, some refs for my forms and such. And this is where I'm loading the Mobilenet, the actual TensorFlow model. And then I am loading my own. To show you how I got this is here. Once I'm done, I hit this, and they give you the code, and they give me the choice of loading it. The regular TensorFlow would be Python based, but TensorFlow.js let us stay in the JavaScript area, right? And I uploaded it here, so Google will actually host it for me. And also I downloaded it so that I can locally run it. That being said, so let's go back to the code. All right, so once everything is loaded up, then I have a small functions, loading image, etc. But this is the most important one. This is where I am actually identifying the images, but I'm giving some conditions. Here I gave it like an absurd conditions. I mean, I'm checking through my TM model, which is Teachable Machine model first. And this is absurd. I mean, I just wanted to show you. That's why, because one can never be reached. I mean, it's almost never 100%, right? So I'm going to disable that. But as I trained my model, I know that my model, whatever image I trained that with, if I show them with similar images, it recognizes them at 90% level. Probability is 90%. So once I'm checking through my own model, and I'm giving it a limit, like if you find 90% accuracy, then go show my model, use my model. If you don't, then fall back onto the Mobilenet model, right? And here's the rest of the code. It's usual, some use effects, some on change events, And this is the rest of the JSX. It's really simple and normal. So now that I've made my changes, so I'm going to go ahead and go back to the application. And just remember, now it just recognizes convertible and cab and whatever. So let's refresh and reload my models. Taking a bit of time because it's loading two separate models. So now I'm gonna go with first the usual, what I was testing it with. Let's say get a dog here, identify, boom, Eskimo Husky, right? Now let's find an object, let's say the laptop, and we get a laptop. But now we're gonna go back to pick up on my own model stuff. Let's say Captain Nightman. So boom, look at that. So now all of these change because this time it actually used my model and comparing among them, themselves. So NIMAT has a 99% accuracy. It recognized it. So now let's try this guy, Major NiHat. Boom, look at that, 99%. And what it insulted my Beamer with before calling it a cab, let's see what it says now. Boom, right there, this Beamer. And let's go with the other guy. Let's find this guy. And understand, none of these images were used in training. Similar images were used, but none of these were used. So now the AI is, picking them up. My model picking up these images, and the Mobilenet is picking up these images. And that's all about this project here. But let me show you some others. All right, so this is a project, another proof of concept. This time I'm using speech to command, TensorFlow model. By default, this comes with these few words, but it can be trained, even though in this project I haven't been training it. So let's see, I'm going to hit this command and then start speaking to it and see if it registers. So let's get started. 1, 2, 5, left, right, 0. Okay, so at this point, I've decided to push it a little bit farther. In this application, I'm gonna add some graphics to it. So I'm gonna start over again. See, command 2, 5, 9, 0, 1, 7, left, left, up, up, 5, 2, 9, right, right, down, down. All right, so that's about it for this proof of concept. Now let's take a look at the code behind. All right, so here I'm loading all the dependencies and some basic states being declared. And this is the recognizer where the model will be recognizing stuff. And here using the use effect to load the model up. And this is the listen action. Initially, I set a timeout so that it would turn off after a little bit, but I disabled it just for this demo's sake. And the rest is very simple, pretty much create React apps base screen, but I just added some stuff to it, not much to it. And now let's go to the next project. Now this is a small proof of concept based on Google's model BERT. This is a Q&A model. This is also another TensorFlow.js model. So here, I'm going to insert some text in here as a context, and based on that, I'm going to be asking some questions and see what kind of answers I get. right? So let's grab some text, pasting it right here. Now this is about some Next.js type questions like SWR, stale while revalidate. This is a data fetching function, and also the ISR, the incremental static regeneration. These are all the Next.js stuff. And now I'm going to ask it a few questions based on these. Like, for example, what is SWR? There you go. So now, actually, let me make this screen bigger. So these are the answers it found related to this context, and these are the probability level, that which one, how much sure that this model is about that question answer. I'm going to put in some a bit larger questions like what is stale, what is the meaning of stale, right? Because I have it somewhere, the exact meaning when I hit it. So this is not properly answered, but then again, if you be specific, what is stale? Oh, it finds stale means old, because somewhere in the text it actually says that right here. So it just found the correct answer. Now let's go ask it, what is ISR? Static regeneration, but we'll get a better answer, I think. What does ISR stands for? So let's ask that. Now it found incremental static regeneration. So basically, the more text is given, it's going to find a better answer. And I was experimenting with this mainly because I wanted to think about a use case where you can actually put in the text in the back end, your company related text, and give some question answers and create like a your own little chat bot for the company, right? So that's about it for this model. And now let's look at the code quickly. Another basic React app. I'm loading up the dependencies right here. This is the main dependency model Q&A. Here I'm loading the refs for my inputs and the states, answer and model, the function for loading the model, function for answering the question, and use effect to load the model, and the rest is simple JSX for the UI UX. And that's about it for this project. Let's move on to the next. Now, this is the last project I have. This is dependent on a third-party API, which is based on a whole bunch of other TensorFlow models. This is called FaceAPI. Like, for example, if I pick it out, a normal picture that it hasn't been trained. Now, this is going to go ahead and find the face, but it's going to say unknown, right? But when it is trained, for example, here, I load them up, and now here it's recognizing Tony Stark, Thor, Captain America, and the rest are unknown because they haven't been trained on it. I also personalized it by, introducing Major Nihad, and look, it just recognized him, and Captain Nymat here. Look at that. And last one should be both of them in one picture. Sorry. Right there, both. And let's go, and I intentionally kept it very simple. Let's look at the code. This was done in vanilla JavaScript. Initially, I'm using a promise all to get all the models loaded. This is where I have all the models based on the face recognition API called FaceAPI, and they are training their APIs based on this SSD Mobilenet models. These are the original, like tiny face detector, etc. These are the original TensorFlow models created by Google. And this is where I am having my labeled images. This is where I'm putting like added just 2 images per label, just to keep it short and sweet. And now let's walk through the script here. Mostly this to begin with, most of these are canvas code created to make those boxes around the faces. And this is where the results will be put through a loop, so that each box, each recognized face will be covered by a box. Or even any face not even recognizes, but if it detects a face, it's going to put a square box around it. And here I am putting the labels that I trained, and they will go one by one, put through a loop. And here I'm hard coding it two images per label, just to keep this demo short. And now this will collect those images and then pass them through the FaceAPI for detection. And eventually, FaceAPI will return the label and the description of the face. And that's pretty much it. But here is the last but not least. Here's something I used for used my webcam, but since I don't have 2 of them, so I recorded it. So this will actually use the FaceAPI to recognize the facial expression. Let's look at it. So it's happy, and then it's trying to detect the sadness, and then perfectly detected surprise, happy back, and that's pretty much it. And that concludes this video. Thanks for watching.